In this session, I will discuss another complex angioplasty done on left main bifurcation with calcified lesion under IVUS guidance with rotablation. This patient is a 63-year-old male who has triple vessel disease from 2003, advised bypass surgery but didn't undergo due to financial reasons, came with a progressive angina, almost intolerable angina leading to crippling lifestyle, and with a normal sinus rhythm and good LV-RV function. He is diabetic as well as hypertensive. So angiogram done revealed, you can see a distal LMCA, significant lesion, with lesion extending into ramus, LCX as well as LAD. And there is a huge chunk of calcium sitting in LMCA and LAD. So RCA was fine, so mild disease throughout, and there is a small dissection probably in distal RCA, and with a total occlusion of PLVB, and this PLVB is filling from left system from ramus. So it's a class 3 angina with good LV-RV function, triple vessel disease and LMCA disease, calcified vessels, and patient not willing for CABG and is diabetic and hypertensive. So we planned PCI straight away as he is not willing for CABG, and to look into the strategy of PCI. So which one to do first, left system or right system? So right system, PLVB, he had total occlusion since 2003. So for his symptoms presently, left system is the main reason. That's why we decided to treat left system first. And what are the issues in left system? It's LMCA, trifurcation LMCA, and there is calcium in fluoro, and there is a size disparity from LMCA to LAD. So, and decision based on these issues is, we decided to treat LMCA trifurcation as bifurcation, as LCX is a small vessel and no significant branches, as well as it is filling from ramus retrogradely. And we planned rotablation based on IVUS findings, and probably to address size disparity of LMCA to LAD, we decided to go with a 3-stent strategy, that is 2 stents from LMCA to LAD, that is based on IVUS. So during procedure, we passed 2 wides, one into LAD, other into ramus. I tried negotiating IVUS catheter into LAD, but I couldn't, despite predilatation with 1.25, 1.5 mm balloon. And then I ended up in doing IVUS from ramus. So this is IVUS from ramus, which showed ramus has a 2.5 to 75 mm vessel, and not much of calcium in ramus. And you can see this is a trifurcation, and this is LMCA showing calcium all around, almost more than 300 degrees, with a small gap here and here at 8 o'clock and 3 o'clock. And this is LMCA, which is about 4.1 to 4.3 millimeters in size from media to media. So looking from this IVUS from ramus, and calcium sitting in almost all the sites of LMCA, so we decided to go ahead with rotablation. And to decide on whether to rotablate from LAD or ramus, so we can see the distribution of calcium and its relation to the IVUS catheter or respective wides. If we see here, so this is LAD wire, you can see, and once LAD wire is joining LMCA, and if you see the relation with calcium, so major chunk of calcium is on LAD wire. So, but there is also calcium on ramus side in LMCA. So in this case, I thought both rotablation from LAD as well as ramus will really help in ablating calcium better. So But as LAD couldn't pass with the IVUS catheter, so I decided to rotablate LAD first. So we did, and once rotablation from LAD is completed, you assess for any dissection in LAD, because any dissection in LAD will bar your rewiring. That's why if there is any dissection, proceed with stenting. Don't proceed with ramus ablation. If there is no dissection, you can ablate from ramus. So with this, we decided to ablate from LAD with 1.5 bar, almost 8 cycles with 15 to 20 seconds of each cycle. And at the end of ablation, we could notice small dissection happened in LAD with IVUS, and we dilated with 2.5 12 mm balloon this entire LAD as well as ramus. So as there was dissection in LAD, in IVUS, we decided not to go ahead with ablation from ramus, which may create problems in rewiring LAD. So you can see these are the images of IVUS after rotablation with 1.5 bar. You can see there's a huge chunk of calcium pre-ablation and IVUS, and this is a post-ablation IVUS showing almost only 45 degrees of calcium, 45 to 60 degrees of calcium. Nearly rest of the thing is ablated. And what remained is from ramus site, and whatever is there from LAD site is completely ablated as we ablated through the LAD wire. So this is a kind of furrowing effect which we can use for better ablation of LMCA. These are the IVUS's pre-ablation IVUS from ramus, and this is a post-ablation IVUS from LAD, so which shows nearly significant chunk of calcium is gone. So you won't see calcium beyond 90 degrees here. So, and this is a dissection which is observed post-rotablation in LAD. You can see there is a dissection, there is a calcium chunk, and the dissection is extending into the subintimal space. So, so once ablation is done, we have to decide on stenting strategy. So, based on LAD to ramus angle, which is around 40 to 45 degrees, and the presence of disease in ostial ramus in IVUS, we decided to go with either mini crush or decays. So I went ahead with mini crush in this case. And as the size of ramus is around 2.5 to 75, so we took a 2.75 to 28 Promus Premier for ramus, followed by crush with the 3 balloon, followed by LMCA to LAD stenting strategy. So this was a plan. And for LMCA to LAD stenting strategy, so what you need to know is size of the vessel. So the disparity of vessel size from LMCA to LAD is too significant. So that's why I have to choose a 2-stent strategy. And you can see this is the distal LAD reference, which was about 2.75 to 2.75. And this is the reference at diagonal. So at the diagonal, so you can see this is the distal to diagonal, it was around 3 or 3.3, and then this is proximal to diagonal LAD around 3.8 millimeter, that's media to media, and this is ostial LAD which is almost approaching 4.1, that's size of the LMCA is 4.4. So there is a size disparity. So in this case, we decided to use a 2-stent strategy. Distal stent is about 2.75 and proximal stent is 4 millimeter. And to decide where to overlap, so we can choose a point of overlap by IVUS. So in this case, so immediately distal to the diagonal, the size was 3 millimeter, and proximal to the diagonal, the LAD size was almost 3.8 to 4. So I can take my proximal 4 millimeter stent up to diagonal, so not beyond diagonal. So that is ideal strategy. So your proximal stent size is size of LMCA ostium to the diagonal plus 3 millimeter, and your distal stent is from diagonal to your distal reference. So with that, we have chosen stent sizes and then went ahead with Ramus stunting. So we stunted Ramus with 2.75, 28 millimeter, and crushed with 3 millimeter balloon, and then did an IVUS. So observed some under expansion at ostium and mid of the stunt, so which we have to dilate subsequently. Yeah, then we went ahead with LAD stunting. So this is a distal stunt of LAD, 2.75 into 28, so which we deployed, and then we took another proximal stunt, which is 4 into 20 millimeter, and we deployed. Then we did part with 4.5, as LMCA size was almost 4.3 from media to media. In IVUS, we took a 4.5 into 8 millimeter and did a part. And then we recrossed LCX through the distal stud, which was confirmed by IVUS. And then we post-dilated Ramus stunt with 2.75 by 15 NC. And then we did kissing with a 2.75 and 3.5 balloons. Then we did a report with 4.5 balloon, and this is a final result after, pot and report. So this is aleocaudal showing good expansion of stunts. So, and we did IVUS, which showed Ramus, ostial Ramus size as more than 5 mm square, and ostial LAD around 9.2 mm square, and polygonal confluence around 8.2, and distal LMCA around 9.6, and proximal LMCA around 10.2. So it's ideal reference areas which we got. So just to recap the whole procedure, so we wired LAD and Ramus. IVUS couldn't pass into LAD. We did IVUS from Ramus. Based on that, we decided LMCA calcium is beyond 300 degrees, and size around 4 to 4.5. Ramus size is 2.5 to 7.5, not much calcium. So we went ahead with rotablation with 1.5 BURR from LAD, and there was a dissection happened. So that's why we avoided ablation from Ramus, and IVUS showed a good ablation from LAD. And then LAD Ramus angle was less than 45 degrees. That's why we went ahead with mini crush, as ostial Ramus is significantly diseased, with a Ramus stunt of 2.75 by 28 and LAD 2-stunt strategy based on IVUS sizes. And then pot, kissing and report, which completes the procedure. And final IVUS sizes of ostial LAD Ramus and polygonal confluence and LMCA. So the conclusion from this case is IVUS makes you wise to choose rotablation before stunting, and this especially important in LMCA because here it guides you in ablating from LAD versus LCX, Ramus, or both based on calcium distribution. In LMCA to LAD stunting, IVUS brings accuracy into stunt diameters, lengths, and overlap zones. IVUS guides you in choosing accurate size of kissing balloon and pot balloon, and final IVUS references of 5, 6, 7, 8, 9 needs to be achieved for good long-term outcomes. Thank you.